Hello, my name is Jingonelli, and today we are going to be looking at binomial distribution. But before I begin off, I'm going to require you to subscribe to the channel. It will bring you some good luck in your forthcoming exams. So before I introduce binomial distribution, remember we are looking at probability distribution, and we have reached this area whereby we are looking at the types of probability distribution, and we're having the discrete probability distribution and the continuous probability distribution. But under the discrete probability distribution, that's where we find the binomial distribution and also the Poisson distribution. Then with continuous, we are having what we call normal distribution, and under it we are having the standard normal tables, what they call standardizing. So make sure you watch the previous videos before this, the videos that were before this video, and then the videos that will come after. That means for the next videos we shall look at the Poisson distribution and even normal distribution and the standardizing. So focusing on the binomial distribution, there are some probability situations that may result into only two outcomes or even be reduced to only two. So such situations may include when a baby is born, it may either be male or female. So a company producing items that are either effective or ineffective. So all the above mentioned situations are called binomial or Bernoulli experiments. So under the outcome of a binomial experiment are classified as successes or failures. So the outcome can either be a failure or a success. So looking at some of the properties of a binomial distribution, we're having the binomial experiment has a number of repeated trials. So it must have a number of repeated trials. We're having the repeated trials are independent of each other, and then each trial results into only two possible outcome, that is a success or a failure. Then we are having the probability of a success is represented by P, and then it is always constant for the repeated trials. So having known that, the discrete random variable x is always the number of successful outcomes in n trials. So with that, if the above conditions are satisfied, then x is said to follow a binomial distribution. So the notation is written as x is following a binomial distribution when it's having number of trials, that is the n number of trials, and p it's having the probability of success, which is p. So these are known as the parameters of binomial distribution. So they're known as the parameters of binomial distribution. So writing the probability of failure as q, where q is equal to 1 minus the p, which is our probability of success. So if I'm having x as a binomial distribution and as having its n and p, the probability of obtaining r successes in n trials is represented by probability of x is equal to r. So this is where we are going to apply in this formula. So this is going to be our formula for the binomial distribution. Probability of x, capital letter X, is equal to r. Sometimes you can this can also be small letter x or r, any that you want, which is equal to, now this is n c r. Okay, this is the whole formula for whereby r is equal to 0, 1, 2, and then these are n trials for the trials. So this is the formula. Yeah, you can note it down, or it can be this: probability is equal to n factorial divided by small x factorial brackets n minus small x brackets, then you put a factorial, and then you just add these, the p and q, then you give them their powers, which is this is n minus x, which is this. So these are the formulas. You can note them down, but for examination purposes, let's always use the above formula. It will ease time. It will enable us finish the paper in time. So where x is the probability of n successes and n is the number of trials Then P is the probability of success on any given trial, and Q is the probability of failure on any given trial, whereby Q is always equal to 1 minus P. So for n factorial and x factorial, we get to move like backwards. So for example, if we are having 4, so here it is maybe n times n minus 1 times n minus 2 till you reach 1. Still with this x minus 1 times so you go on moving backwards. This should have been a 2 here. So let me see. Okay, it should have been a 2. This should have been a 2, and this should have been a 1. So this should have been a 1, and this should have been a 2 there, and this should have been a 1. Remember, I'm moving backwards, so from 2 up to 1. So if this were 3, from 3 2 up to 1, from 3 2 up to 1, like that. So if I'm having 4 factorial, it is 4 up, from 4 up to 1. So on the calc, let me show you how you get to do it. So for 4 factorial, you're going to press 4, shift, and then you go to this symbol, and then equals, you get the 24. So after pressing it on the calculator, the next thing is we're having here an example. Example 1. A coin is tossed 3 times. Find the probability of getting exactly 2 heads. So with this, we're having solution 1. You can either find it like this. When you say like the probability can be solved by looking at the sample space. So there are 3 ways of getting 2 heads. That is by this, this, and this. But we are looking for 2 heads. So this one is having 2 heads, and this one is having 2 heads, and this one is having 2 heads. So out of the 8, I'm having 3. So the answer is going to be 3 out of 8, which is going to give me, in decimal places, which is going to give me 0.375. So what is the other way of finding this? So the other way is looking at the problem above. From the standpoint of binomial experiment, one can show that it meets the 4 requirements. You all remember the 4 requirements. So there are only 2 outcomes for each trial, that is head or tail, and there is a fixed number of trials, which is 3. So the outcomes are independent of each other. So the outcomes of one toss in one way does not affect the other outcome, of another toss. So the probability of success, that is heads, getting heads, is 1 out of 2 in each case. So in case you're having n as 3, x or r are equaling to 2. So here you can use x or you can use r. So p is equal to your half. Remember, to get q, it is 1 minus the p, which is a half. So meaning our q is also 1 out of 2. So hence substituting into the formula. So we are going to use this formula here, where the formula, this one above here, and then we substitute it in. Now this is the simple way of doing it without using the factorials. You just have a probability of 2 heads is equal to this. So let's do it on a calc so that we get our 0.375. Let me show how you do it. So make sure you have cleared your calc. So you're going to press 3, shift, division sign, you get that, and then you say 2 times the brackets, which is 1, go to this symbol, then I get the 2 to give you the half, then to the power 2, and then times, and then open brackets 1 out of 2, and then close bracket to the power 1, and then you go to equals, you get that. Then to change it to decimal, you say just press that symbol. So that's how I got my answer. So after getting your answer as this, which is the same answer obtained by using the sample space. So for more examples, you may be given at least two projects, which means 2 projects or more. This can also mean the minimum is 2. So it can mean probability of x greater than or equal to 2. So this is how you present it in probability format. So at most 2 projects means 2 projects or less. It means the maximum is 2, which is represented by probability is equal to x less than or equal to 2. So if they give you, in the question you're having not more than 2 projects, it means 2 projects or less, which is the same as probability x less than or equal to 2. And for more than 2 projects, it means above 2 projects and the 2 is not included, so it will be probability x greater than 2. So for less than, it will be less than 2 projects. It will mean 2 projects and the 2 is not included, which will be x less than 2. So here we're having an example, a probability that a pen drawn at random from a box of pens is defective is 0.1. So this is success, a probability of success. If a sample of 6 pens taken from the probability, if a sample of 6 pens taken, find the probability that it will contain no defect pens, 5 or 6 defect pens, less than 3 defect pens. So this is how we are going to do it, a simple way, and even we save time. So we know our n is 6, our p of success is 0.1, and to get the q, which is the failure, it's going to be is going to equal to 1 minus 0.1, which is going to give us 0.9. So our q is going to be 0.9. So let number of defect pens, so x is going to equal to the number of defect pens. So if at all they're asking us for no defect pens, it's going to be probability of x is equal to 0, which I'm going to say, when I apply in the formula of binomial distribution, so I'm going to press this same thing on my calc to get the 0.531. So let me show you how to do this in the simple way. So going to press, this is going to be 6, then shift, then you go to the division sign, brings you a C, and then you go to 0, and then you will say times, and then you will say brackets 0.1 brackets, you close it, then to the power, that is 0, then times open bracket 0.9, then you close it, then to the power 6, and then after that you go to equal sign, and that will be your answer for the first one, which I rounded to 4 decimal places. So after getting your answer, you come here to probability of 5 or 6 defect pens. Now with this you apply the same formula, x is equal to 5 here, x is equal to 6. So you apply this, and then this is the formula, you get this plus this. So you know where I've gotten all this stuff, so from the formula. So now this one, it is tricky, so let me show you this one here. Let me show you how they can compute it very well, so that they get answer this, and same will apply to this one, so that they get answer this. So let me show you on the calculator. Be critical of how we are going to get this answer here. So this one, it's very tricky, so but I'm going to show you the easy way of getting it. You're going to go to 6, shift, division sign, then you go to 5, and then times brackets 0.9, 1 close bracket to the power 5, and then times brackets 0.9, then close bracket to the power 1. After getting that, you say equals. Now you're getting such an answer. So how do you change it? You're going to go to mode, press it 2 times, 1, 2, and then you see standard SD, you go to 1. So after pressing that, again you press mode 5 times, 1, 2, 3, 4, 5, then you see normal, then you go to 3, then you press 2, then from there you say answer equals. So it will change to 0.00054. That's how they got that answer. So after getting our answer there, we add it to this. After you still applying the same thing as you did to this one, then you get 0.00055. So that is that. And then with the last one, less than 3 defect pens, it's going to be probability x less than 3, which is the same as when you say probability x less than or equal to 2. So it's going to equal to less than or equal to 2 is going to be 0 plus even a 1 plus even the 2. So you just apply this to this and this, and then you'll be good to go. You get your answers from the calculator like how I showed you the simple way, and then you'll get your answer as this. So thank you so much for watching, and if at all you want to clear your calculator, still I've already showed you how to clear it. Okay, let me show you how to clear it. Then how do you clear your calc? You will go to shift mode, then you go to 3 equal signs, then equal signs. There it will be cleared. So guys, that's how you clear your calculator. So thank you so much for watching. Make sure you subscribe to the channel.